Hi everyone. In this video, I'm going to solve another problem from operating system topic and specifically CPU scheduling. As you see here, we need to use preemptive shortest job first scheduling algorithm, and we have four processes with different arrival time and different burst time. The first step is to show the arrival time of different processes, and I use a timeline which helps me to understand at what time which process arrives. At millisecond 0, P1 arrives, millisecond 1, P2, at millisecond 2, nothing will happen, and millisecond 3, P3, and at millisecond 4, P4. Don't forget, this is preemptive shortest job first, and it is very important to know that because we are using preemptive shortest job first, preemptive algorithm, at any given time, we are able to stop the process and give the CPU to another process. It means that we can switch between different processes based on their burst time. For this purpose, what I do for the Gantt chart, which is very important, I show the arrival time of each process here because it helps me to know at what point I need to stop and look at the different processes and their burst time. So this is millisecond 0, millisecond 1, P2 arrives, millisecond 3, P3, and millisecond 4, P4. So in that case, I know what happens and I actually switch between different processes. We are at millisecond 0 and at this time only P1 arrives. We are here. So because only P1 is here, there is no other process. Definitely P1 gets CPU time. We get to point 1. Millisecond 1. Don't forget, 1 millisecond has already been used, so 5 milliseconds remains from the burst time for first one. Now in second one, we've got two processes, P1 and P2. We look at the burst time. P1 is 5 milliseconds, P2 is 2 milliseconds. Which one is shortest? P2, definitely. In that case, P2 gets CPU time for 2 milliseconds, and in that case, nothing remains from that, so P2 exit the CPU at this time. Now we are in millisecond 3, we've got P1, P2, and P3. P2 technically is 0, nothing. Now we need to choose between P3 and P1, P3 and P1. Which one is shorter? P3 is 4 milliseconds, P1 is 5 milliseconds. So definitely P3 gets CPU time. P3 gets CPU time, but when we get to millisecond 4, P4 arrives. It means that now we can switch if we want, if actually a shorter job arrives. So 1 millisecond goes, so in that case P3 is only 3, we are at second 4, we are here and we can choose. As you see, P4 is 1 millisecond, P3 is 3 milliseconds, and P1 is 5 milliseconds. So who is the shortest? Definitely P4. So P4 gets CPU time here. P4, and second, it leaves the CPU at second 5. Now between P3 and P1, P3 is the shortest, 3 milliseconds. This is P3. Nothing remains from that. We are in millisecond 8, and the last one, which is the only one that actually remains, is P1, and nothing remains, and it actually leaves at 8 plus 3, which is 13. This is the most important part of the question. The correct Gantt chart helps us to actually answer all the question. What I do next, I need to show and add another column to this, which is the exit time. Exit time, what I do, I always start from right to left. So P1 leaves at millisecond 13. The next one is P3, which leaves at millisecond 8. The next one is P4, which leaves at millisecond 5. And the next one is P3. We've already mentioned that. P2 leaves at second 3. Now we've got the exit time. The next column that we need is turnaround time, turnaround time, turnaround time. This column, as turnaround time is exit time minus arrival time. So what you need to do, subtract these two columns. So 13 minus 0 is 13, 3 minus 1 is 2, 8 minus 3 is 5, and 5 minus 4 is 1. The next column that we need to add is waiting time. The waiting time, which is the turnaround time minus birth time. So what we need to do, this is waiting time. I need to subtract these two columns. It means that 13 minus the original values minus 6, which is 7, 2 minus 2, which is 0, 5 minus 4 is 1, and 1 minus 1, which is 0. It makes sense actually, because if you look at the Gantt chart, you will see, for example, P2, as soon as it arrives, it gets CPU time, so the waiting time is 0. P3 should wait 1 millisecond for that, because actually 1 millisecond of that is given to P4. So it looks good, and what we need to do, just calculate the average waiting time and average turnaround time. So it's very easy. For example, finding the average of turnaround time, what you need to do, just add this column and divide it by 4, because you've got 4 processes. 13 plus 2 plus 5 plus 1 divided by 5, which is 21 divided by 4, which equal with 5.24 millisecond. So this is average turnaround time, 5.25, and the first the other one is the average waiting time, which is equal with 7 plus 0 plus 1 plus 0 divided by 4, which is 8 divided by 4, which is 2 millisecond. This is how we solve a preemptive shortest job first scheduling algorithm, and I try to explain all the steps in this question. Thank you very much.